Hello guys, let's solve this definite integral using substitution method. I'm going to let u as ln x, and differentiating both sides I'll get du equals to 1 by x dx. Now we need to find the limits over here. So x equals to e to the power u when you raise both of these sides to the power of e, or what I meant was e to the power of both of these sides. And here when x goes to 0, when x goes to 1, u goes to 0, and when x goes to infinity, here u goes to infinity. So that means our new integral will go from 0 to infinity. Ln x is our u, and 1 by x dx is our du, and here we have a remaining 1 by x, which will be our 1 by e to the power u, and here u by e to the power u, we can write it as u into e to the power minus u, and we can simply solve this using the di method. So like this, and here we'll put u over here, differentiating 2 times, we'll get 0, and e to the power minus u will get minus e to the power minus u, and e to the power u, and this will multiply that, this will multiply that. So this integral is minus u into e to the power minus u minus e to the power u, going from infinity to 0. And let's clean this a little bit up. We can take minus e to the power minus u common, so we'll have u plus 1 going from infinity to 0. And here this negative sign switches the inequalities, or sorry, the limits. So we'll have e to the power minus u 1 plus u going from 0 to infinity. So here when we plug in 0 over here, we'll get e to the power minus 0 1 plus 0 and e to the power minus 0 is just 1, so this thing right here is 1 minus, and now over here e to the power minus infinity 1 plus infinity. Now e to the power minus infinity is 0, and this is infinity, so we have an indeterminate case. Now we have to go to the limits form to really see what this limit actually is. So this is basically as u going to infinity 1 plus u, and we can rewrite e to the power minus u as e to the power u. And here this is now a infinity by infinity case, so we can use L'Hospital's rule, and now this will simply be 1 by e to the power u, and when we apply this limit here, this will go to 0, so that means this whole limit is 0, so minus 0, and finally this limit or this integral is 1. Thank you.